guys, I gave you 30 questions from mechanics. I hope you have done those 30 questions. If you could get more than 25 out of those 30 questions, that means you are great. And if you couldn't get the answers correct, that means you have to go through with your theories again, right? In the same manner, I am giving you 30 questions from waves and oscillation today. So if you can get at least 25 out of 30, that means you are good with your small theories. I mean, you know theories, right? So these questions are very easy. Just go through with it, find the answer, and if you could get the answer, that's great. That means you know the theories. So let's get to the questions.
All right, moving into our very first question. Let's read it. A simple pendulum is oscillating in a lift. If the lift starts moving upwards with a uniform acceleration, the period will remain unaffected, be shorter, be longer. Right. Keep reading. Try to get the answer. Right. Just get your answer and then move forward, then only you will see the answer. Right. So t equals 2 pi root log, of course you know this. So when it is going up, the lift is going up, the acceleration will be g plus a, so the time period will be shorter. Answer B, second answer. Right. Moving into our second question. If a hole is bored along a diameter of the earth and a stone is dropped into the hole, it will. Right. Read the question. Just hold it there, read the question, get your answer, then move forward. Right. Now we are moving into the answer. So what actually happens is when it is inside of it, towards both sides there will be an acceleration. When it goes up, there will be an acceleration to the other side, and so both ways there will be an acceleration. So the answer is C. It will execute simple harmonic motion. Right. Moving into third question. In order to double the period of a simple pendulum, yes, read the question, try to hold it there, try to find the answer, then move forward. Same equation, t equals 2 pi root log, just to double the period. So L should be, yes, because we have the root value, its length should be, yes, quadrupled. Second answer B. Right. Fourth question. A particle is executing simple harmonic motion, then the graph of acceleration as a function of displacement is straight line, circle, ellipse, hyperbola. Alright. Think of the answer. Now moving into the answer. Actually the equation is a equals minus omega squared x. So acceleration is directly proportional to x. So the function straight line, that is the answer A. Moving into our fifth question. A girl is swinging on a swing in the sitting position. How will the period of swing be affected if she stands up? Think of the answer. Just hold it there, think of the answer and move forward. Then let's get into the answer. The period will now be shorter. It's for the fifth one, answer is A. Question number 6. A pendulum clock is said to give correct time at sea level. This clock is moved to a hill station at an altitude of 2500 meters above the sea level. In order to keep the correct time on the hill station, the length of the pendulum. Right. Think of the answer. T equals 2 pi root log, same here. When it goes up, actually the acceleration will be reduced, so the time period will be increased. So to decrease the time period, we have to increase the length. So the length of the pendulum has to be increased. B is our answer. Moving into 7th question. Mechanical waves are longitudinal waves, are longitudinal only. are transverse only, can be both longitudinal and transverse, require medium to propagate. Actually here we get couple of answers correct. Can be both longitudinal, yeah, D. From this question onwards, actually you will be getting couple of answers correct. So I just want you to think of the real answer. Even A, B, C, 3 answers can be correct. Right, moving into 8th question. With the rise of temperature, the speed of sound in a gas. Hold it there, think of the answer, then move forward. I am repeating this again and again. Hold it there, think of the answer. With the rise of temperature, the speed of sound in gas. Right, we need an equation. V equals root 3 RT over M. So increase of temperature, speed of sound in gas, it will increase. Right. Moving into question number 9, the velocity of sound in air is affected by change in the atmospheric pressure, moisture, temperature of air, composition of air. Right, think of the answer. V equals root 3 RT over M, same concept. Atmospheric pressure, it's not there. Moisture content of air, M. Temperature of air, T. Composition of air, again M. B, C, D, all correct. Moving into question number 10. Decibel is a musical tone, musical instrument. Unit of intensity level. Right. I hope you know the answer. D, unit of intensity level. Moving into question number 11. Doppler shift in frequency does not depend on the actual frequency of the wave, the distance of the source from the listener, the velocity of the source, the velocity of the observer. Does not depend on. Right. It's B, the distance of the source from the listener. Actually that is intensity. Frequency does not change from the distance. Okay, question number 12. The Doppler effect is applicable for, think of the answer. Yeah, light waves, sound waves, space waves, both A and B. Light waves correct, yes correct. A and B, that is good. Correct answer, both A and B. So D is our answer. Moving into question number 13. Sound waves of wavelength greater than that of audible sound are called infrasonic, ultrasonic, sonic waves. Right. Think of the answer. Remember, wavelength is greater than the audible sound. So F is smaller compared with the audible one. So it's smaller. Infrasonic. Question answer A, 13. Moving into 14th question. With the increase in temperature, the frequency of the sound from organ pipe. Easy. V, again gamma RTOM. Easy answer. Temperature increases, velocity increases, so the frequency increases. Question number 15. In a stationary longitudinal wave, nodes are point of, think of the answer. We get, let's say, a node. So this is a node. So at the node, pressure is maximum. Actually it's pressure variation that is maximum. So answer is D for 15. Right, moving into the 16th question. Two waves of the same frequency and intensity superimpose with each other in opposite phase. Then after superposition, yes, read and think of the answer. Moving into the answer, one wave, if it's like this, the other wave, it will be something like this, completely opposite. So opposite phase, the phase difference will be Y. So we can conclude, yes, it's a destructive interference. So the answer is not there. D, none of the above. Moving into 17th question. Standing waves can be produced on a string clamped at both ends, on a string clamped at one end and free at the other, when incident wave gets reflected from a wall, and D, moving in the same direction. Right. On a string clamped at both ends. Possible? On a string clamped at one end and yes, possible. When incident wave gets reflected, yes, possible. A, B, C. Moving into 18th question. Beats occur because of interference, reflection, refraction, Doppler effect. I hope you know the answer for this. Beat occurs because of constructive and destructive interference. So if this is a beat, one beat, here we have destructive interference and here we have constructive interference. So it's basically interference. Answer A. Moving into question number 19. Sound travels faster in steel, air. Yes. Easy question. In steel. Question number 20. Ultrasonic waves are used for stirring liquid solutions because they do not produce noise. We don't need noise here actually. So think of the answer. Do not produce chemical reaction. Answer D. Question number 21. The velocity of sound in air is affected by change in. Yes, think of the answer. Atmospheric pressure, moisture content, temperature of air, compression of air. Actually, you might have seen the very same question at the beginning of the questions. Anyway, 3RT over M again. So there's no pressure inside of this. You might think there's another equation, gamma P over rho root. Even if we increase pressure here, with pressure actually the density also will increase, so it will cancel out. So no effect from pressure. Moisture content, yes, rho. Temperature of air, of course. Compression, again M will change. So B, C, D. Moving into question number 22. When a source of sound is in motion towards a stationary observer, the effect observed is. Easy answer. Yes, Doppler's effect, increment of frequency. Moving into question number 23. To raise the pitch of a string musical instrument, the player can pitch. Think of the answer. Actually, in pitch, there's a connection with frequency. So how do you increase the frequency? Frequency of a stretched string, F equals 102L root T over M. So T is tension, L is the length. So loosen the string, tension is decreased. Raise the pitch, so cannot, yes, it's not possible to increase the frequency. We have to tighten it. So B is correct, and shorten the string, again correct. Yes, B, C is our answer. Question number 24. Question number 24. The quality of sound produced by an instrument depends on frequency, intensity, number of photons, none of these. I hope you know the answer for this, number of photons. Question number 25. Doppler shift in frequency does not depend on actual frequency of the wave, the distance of the source from the listener, and velocity of the observer. Actually, it does not depend on. We actually came across a question like this again, distance of the source from the listener. Question number 26. As a wave propagates, the wave intensity remains constant for a plane wave. No. The velocity, intensity, The wave intensity decreases as the inverse of the distance. The wave velocity. Okay. Read the question and think of the answer. Actually, intensity I equals power area, so 1 over 4 pi r squared spherical. So the wave intensity decreases at the inverse square of the distance. Yep, answer C, 26. Moving into question number 27. When two sound waves are superimposed, beats are produced when they have different amplitudes, different velocities, different phase, or different frequencies, of course. Question number 28. Which of the following statements are true for wave motion? Mechanical transverse waves can propagate through all mediums. Longitudinal waves can propagate through solids only. Mechanical transverse waves can propagate through solids only. Longitudinal waves can propagate through vacuum. Right? Think of the answer. Mechanical transverse waves can propagate through all mediums. No, that's not possible. Longitudinal waves can propagate through solids only. Nope. Mechanical transverse wave can propagate through solids only. Yes. Mechanical transverse wave. It cannot travel inside. Remember, for liquid or air medium. The key point is inside, not through it, not inside. So answer C. Question number 29. Which of the following statements regarding stationary wave is not true? It's not true. Read the question. Moving into the answers, it consists points with zero amplitudes. Okay, correct. It transmits energy. It's a stationary wave, so energy is not propagated. That's why we call it a stationary wave. Distance between is lambda by 2, correct. So answer second one. Moving into our last question, 30th question. Which one of the following is not an instance at which the velocity of the source exceeds the velocity of wave propagating through the medium? Sonic boom. Hearing a distinct sound from supersonic jet, correct. Not, they are asking. Formation of white waves, a tail of fast moving boat on water. Maybe. Observing of a white mist at the tail of aeroplane, high sky. Okay, hearing the bursting, this is actually, you know that it's sonic boom. And observing moving, yes, correct. So answer